Hello everyone. In this section, we are going to discuss about a three-tier client-server architecture. So, in traditional, the client or server architecture involves two levels, or it is also called tiers: a client tier and a server tier. A three-tier client-server architecture is also common like this. The application software is distributed among three types of machines: a user machine, a middle-tier server, and a back-end server. This is a figure of three-tier client-server architecture. Here it is clear that the client and the middle-tier server and back-end servers. So here there is no direct communication between the client and the back-end servers. There is a gateway between them, that is middle-tier server. The user machine is the client machine we have been discussing, and in the three-tier model is typically a thin client. So we mentioned about the user machine. It is simply client in this three-tier architecture. Okay. The middle-tier machines are essentially gateways between the thin user client and a variety of back-end database servers. The back-end database servers is nothing but it is the place where the actual data is stored. When the client requests any data, that data is actually stored in the backend database servers. Okay, so the middle tier machine is gateway between the user clients and the backend database servers. Okay, the middle tier machine can convert protocols and map from one type of database query to another. In addition, the middle tier server can merge results from different data sources. So this is the functions of a middle tier machine. It can convert protocol and map from one type of database query to another, and also can merge results from different data sources. The interaction between the middle tier server and the backend server also follows the client or server model. That means we know middle tier machine can or server can act as both the client and the server. That means when the client produces a request, and it will communicate with the middle tier server, and middle tier server is placing this request in the backend servers, and the actual data is stored, and it will return back to the client. So at a time, a middle tier server can act as both as a client and a server. That's why it is called it can act as a both client and server. Okay, so here is a figure. It is clear from this a three-tier client server architecture and the among the distributed system. Okay, this is our first topic. Next we are discussing about file cache consistency. When a file server is used, the performance of file I/O can be noticeably degraded relative to local file access because of the delays imposed by the network. So we use a file server. There we produces local file access, and the network may be delayed, or it will also called network traffic. This will degrade the performance of file I/O. So to avoid this, individual system use file caches to hold recently accessed file records, and it will reduce the number of remote server accesses that must be made. So to avoid this part, individual systems holding a file caches, it contains only recently accessed file records. Okay. File caching is an important feature of the distributed file systems that helps to improve performance by reducing network traffic and minimizing disk access. So, file caching is the important feature of distributed file systems. This will reduces network traffic and minimizing the disk access. Thus, it will also improve the performance of file I/O. In distributed file system, files are stored across multiple servers or nodes. Okay, and file caching involves temporarily storing frequently accessed files in memory or a local disk. Okay, this will reduce network traffic. Okay, that's all say here. Here is a figure of distributed file caching. It will be explained in the next slide. When a process makes a file access, the request is presented first to the cache of the process's workstation. That is, when a process makes a file access, it will first presented in the process's workstation. It is called file traffic. So here in the figure it is clear that file traffic. If not satisfied there, the request is passed either to the local disk if the file is stored there. So when it is not satisfied in the process's workstation, then the request is placed in the local disk. That is called disk traffic. Okay. And or to a file server where the file is stored. That is called server traffic. So these are the three cases when a process request a file access, and that request is placed in the three places: file traffic, disk traffic, and server traffic. At the server, the server's cache is first interrogated, and if there is a miss, then the server's disk is accessed. So when it reaches the server, the server's cache is first interrogated. That means first checked the accessed file is present in server's cache. If it is present there, it is directly taken from the server's cache. Or if it is there is a miss, that is the file is not present in the server's cache, then only server's disk is accessed. This is like we studied about the cache memory and main memory. The main memory is the place where the actual data is stored. Cache memory is a temporary memory, and it is the fastest memory where the recently accessed data is stored. So when a request to data in a specified memory location, it first look in the cache memory. If it is present there, then it is directly taken from the cache memory. Only when there is a situation that not present in the cache memory, it is go to the main memory. Such like here also, first server's cache is checked, or if there is a miss, then only server's disk is accessed. Okay. Caches are consistent when they contain exact copies for remote data. That means we have remote data means the actual data we store permanently stored. Okay, that exact copies of that data is in the caches, temporarily stored caches also contains, and then we can say that the file caches are consistent. The next point tells about the when this cache become inconsistent. It is possible for caches to become inconsistent when the remote data are changed and the corresponding obsolete local cache copies are not discarded. That means the actual data, that is remote data, it will change. That means it will modified, or any writing to that file is take place, but the cache copies, that means obsolete local copies. Obsolete means not useful copies. Okay, so that not useful data in the local caches are not changed or not discarded. That will cause the caches become inconsistent. So next we say about the what is the reason for this inconsistency caused by the files. Okay. This can happen if one client modifies a file that is also cached by other clients. So at a time a file can be accessed by different clients, and one client modifies a file and that is already cached by the other clients. So what happens? The difficulty is actually at two levels. If a client adopts a policy of immediately writing any changes to a file back to the server, then any other client that has a cache copy of the relevant portion of the file will have obsolete data. The problem is made worse if the client delays writing back changes to the server. That is, the client modifies the server, and the data that already cached by the other client will become obsolete data, that is no, it is not longer useful. The when the problem becomes worse, the the client who modifies data delays to write back that changes to the actual data. Okay, or changes to the server. In that case, the server itself has an obsolete version of file and the new file request. That in that case, the server also contains the obsolete data. So when any other new file access comes, then they also read the obsolete data from the server. That is also an inconsistent data is also in the server. The problem of keeping local cache copies up to date to changes in remote data is known as the cache consistency problem. So, next, how can we avoid this problem of inconsistency caused by the file? File locking prevents simultaneous access to file. That is, in the previous we discussed about the at a time many clients or many processes will request the file. So, avoiding that, locking the files to simultaneous access to avoid the simultaneous access of the file. Any number of remote processes may open a file for read and create their own client cache. But when a open file request to a server request, write access and other processes for read access, the server take to action. That means at a time there is a request for write access and a read access. So it is a file opens for a writing and reading process. Then the server takes two actions. What are they? First, it notices the writing process that although it may maintain a cache. So first is the chance of writing process, and also it will maintain a cache that is that of the modified data. So it will immediately updated on the cache also. There can be at most one such client. Second, the server notifies all the reading processes that have the file open that the file is no longer cacheable. So the before modifying that file, there is a there other processes request for this file to reading processes. Then the server notifies them that this file is no longer cacheable. Okay. Next, we are going to discuss about middleware. To provide a uniform means and style of access to system resources across all the platforms, the developers must have to use a set of rules. This will helps to achieve the true benefits of the client or server approach. This also enables the programmers to build applications that will look like same in on various PCs and workstation, and also they use same method to access data regardless of the location of the data stored. So to achieve this, the most common way to meet this requirement is by the use of standard programming interfaces and protocols that sit between application above and communication software and OS below. So we use standard programming interfaces and protocols that between the application logic and the communication software and operating system below. So between them we use a standard programming interfaces and protocols, and such standardized interfaces and protocols is referred to as middleware. So this is the figure of middleware clients or server architecture. It is clear from this figure that there is an application logic, and it is above and the below communication software and operating system. Between them, we use a set of programming interfaces and protocols. That is called middleware. With the use of these standard programming interfaces, it is also easy to implement same application on variety of server types and workstation types. The operating system provide various essential features that the OS does not offer. It also performs many functions. That is, it manages connections between various backend servers. Middleware components can create connection pools to provide fast and efficient access to popular backend database. It also provide implement a logic based on the client's requirements and so on. There is a variety of middleware packages ranging from the most simplest to the very complex. The most common capability of these middleware packages are to hide the complexities and disparities of different network protocols and operating system. So they will hide the complexities and dissimilarities that can present between network protocols and operating system. And also the client and server vendors generally provide a number of more popular middleware packages as their options. Thus, a user can settle on a particular middleware strategy and then they will assemble to those vendors that support their strategy. Next is middleware architecture. The most main purpose of a middleware is to enable an application or a user to at the client to access a variety of services on his servers without being concerned about the differences among that servers. So next we look at one specified application area, the structured query language, which is a programming language designed for managing data held in relational database management system, which is used to create queries in databases. And a query is a question or a request for data results that was residing in the database. So here we take the application area of structured query language, which is supposed to provide a standard means for access of relational database on either by local or remote user or an application. However, many relational database vendors they also although support the SQL but have added their own proprietary extensions to this SQL. This enables the vendors to differentiate their products but also create some potential incapabilities. So, as an example, consider a distributed system used to support, among other things, the personnel department. The basic employee data such as employee name and address might be stored on a Gupta database, whereas salary information might be contained on Oracle database. Here we consider a personal department, so the details of the employees are stored in different databases. So here the basic employee data like employee name, address, which is stored in a Gupta database, and also the salary related information are stored in Oracle database. So when a user in the personal department personal department requires to access some particular records, that user does not want to be concerned about the vendor's database contains the records needed, because it is stored in the Gupta database and also in the Oracle database. So the user that from a personal department who want to access the particular records don't want to concern about the vendor's database and it is easily accessed by the user. We need to look at the role of middleware from a logical view rather than an implementation point of view. In this figure, the logical view of the middleware architecture is clear. Middleware enables the realization of the promise of distributed client or server computing, and it helps to view the entire distributed system as a set of applications and resources available to users. We know the middleware is residing between all the client and server between the client and server platforms, and so it is responsible for routing the client request to the appropriate server. Therefore, user need not be concerned with the location of data or indeed the location of the applications. All applications operate over a uniform applications programming interface. Application programming interface, which is a set of rules that enable different applications to communicate with each other. Here, the middleware maintains a uniform application programming interface. Although there is a wide variety of middleware products, these products are typically based on one of the two underlying mechanisms that are message passing or remote procedure calls. These two methods are explained in the later sections. That's all about my section. Thank you.